Hi, this is your math coach, Howie Tutman, presenting What Math Should My First Grader Know? I've recorded videos in the four domains or groupings of standards in math for first grade. This video is the seventh of 10 videos in the Operations and Algebraic Thinking grouping. The video is about adding within 10. This is the first of a three-part video. If you have any questions or comments, please email me at hrtutman@gmail.com. The complete text of the standard that this video is based upon follows at the end of the video. This is such an important standard for first graders. It's adding and subtracting within 20, demonstrating a fluency within 10. So by the end of first grade, once again, I can't stress how important it is for these students to fluently know their basic math facts with the single digits. So there's several different strategies that I'll discuss in this video to help first graders be able to learn and know these facts fluently. So here's an addition chart, and it lists our numbers from 0 to 10 across the top and 0 to 10 down the side. And I'm going to break up this standard into two different videos. In this video, I'm just going to discuss our facts within 10. And then in the next video, I'll continue on with the facts within 20. So we're only going to discuss the facts whose sum is given in this chart here. One of the important things is for students to remember what we've discussed before is the commutative property. And once again, I'll stress they don't have to know that name, but it's just knowing that they can reverse or flip or switch the add-ins, the numbers that they're adding. So if they're going to be adding 6 plus 3, that's the same as 3 plus 6. If they're going to be adding 2 plus 8, they can think of it as adding 8 plus 2, which would probably make it easier for them, as you'll see as we go along. So for the first type of facts, it could be adding 0. So anytime that a first grader has to add 1 plus 0, or 2 plus 0, or any number plus 0, they should realize that they're just going to end up with that number that they started with. If they're adding 10 and they're adding 0, they're adding nothing to the 10, and they're going to get 10. Now, if the problem says 0 plus 3, once again, they don't have to count on from 0 to get to the 3. They simply can switch the facts, so it's 3 plus 0. Once again, they recognize that they're not adding anything to the 3, so 3 plus 0 would be equal to 3. The next strategy that I want to mention after our adding 0 is our counting on strategy. And this strategy is a good strategy to use when the first graders are adding 1 or adding 2 onto a number. So for instance, if they're starting with the number 1 and they have to add 1 more, 1 plus 1 would be 2. If they're starting with the number 4 and they're adding 1, 4 plus 1 would be 5. If they're starting with 8 and they're adding 1, the total or the sum would be 9. And like I said, this strategy can be used for counting on 2 also. So if they're starting with 3 and they're adding 2, they're counting on 2, so 3 plus 2 would be 5. If they're starting with 6 and they're adding 2, they're counting on 2. 6 plus 2 would be equal to 8. And once again, if they're starting with 1 and let's say adding 3, once again, they can think of that commutative property, and instead of starting with the 1, they can switch these numbers they're adding, these add-ins around, so they can think of it as 3 plus 1 equals 4. If it was 1 plus 7, they can think of it as 7 plus 1 7 add on 1 is 8. If it's 2 plus 7, they can think of it as 7, count on 2, and that's going to give them a total of 9. And I've shown that here with a couple of examples as far as on the counting on. And once again, if the students, the first graders, need an aid, it's at the beginning because they don't know it right off and they don't know it fluently, they can think of it as 3 plus 1. It's going to be 3 plus 1 is 4. If it's going to be 7 plus 2, they can think of it as these two dots over the 2, and 7 plus 2 would be equal to 9. And same thing, if it's 1 plus 3, they think of it as 3, count on one more dot, will be equal to 4. 2 plus 7, make two dots there, would be 7, 8, 9, and that would be counting on. Our next strategy is making 10 or making combinations of 10. And as you can see, our grid is starting to fill up with using different strategies to add these two add-ins. So for making 10, students can visualize our 10 frame. So for instance, if they're adding 4 plus 6, which equals 10, they can visualize that on a 10 frame with 4 red counters and 6 yellow counters, and this fills up the 10 frame. And with the switching of the facts, that also can be 6 plus 4. In either case, we'd be filling up the 10 frame. So eventually students will just learn their combinations of 10. They will learn that 10 plus 0 equals 10, 9 plus 1 equals 10. And one of the helping aids for them may be to write out the numbers 0 to 10 and create this rainbow so that they can connect the 0 plus 10 or 10 plus 0, 1 plus 9 or 9 plus 1, 2 plus 8, 8 plus 2, and so forth until they get down to the 5, and that would be 5 plus 5 equals 10. So eventually we would want the students to know their combinations of 10, which is so important, as are all of these strategies, but especially knowing the numbers that add up to make 10. Now you'll notice that I've coded these 10s with the blue. Now I could have also coded these other 10s with blue also, because many times students will find for certain sums, there'll be different strategies that they can use. So for instance, 8 plus 2, a student might know that because they know they're counting on 8 plus 2 more will give them 10. Or in their mind, they may be thinking, oh, I know that that's one of the combinations of 10. 8 plus 2 equals 10. So either way, I could put a little blue dot here. So depending on which strategy a student wants, same thing with 9 plus 1. They may be counting on 1, or they may be thinking of it as a combination of 10. 10 plus 0, be adding 0, or once again, it's making of 10. And the same with the add-ins if we were to reverse and switch them around. Another strategy for our first graders is double facts. So that would be like 0 plus 0 equals 0, 1 plus 1 equals 2, 2 plus 2 equals 4, and proceeding on this diagonal here all the way to 5 plus 5 equals 10. So for doubles facts, I highlighted it in purple, and you can see the purple dots here on 6, which is 3 plus 3 equals 6, and on 8, 4 plus 4 equals 8. And then I have these smaller purple dots and 0, 2, 4, and 10, because once again, there's other strategies that the students may have learned. So a student may think of 5 plus 5, and they know that from their making 10 strategy, or they may know it from their doubles facts. Same thing with these others. For instance, 2 plus 2. A first grader may think of it as 2 and counting on 2 to get to the 4, or they may be thinking of it as their doubles facts. 2 plus 2 is 4. So that's why I have the multiple colors on some of these numbers. And for the example here, 3 plus 3 equals 6. And there's no turnaround fact because obviously when I take 3 plus 3 and I turn it around, I will get the same 3 plus 3. And if a student needs a drawing or manipulative to think about this, there could be 3 yellow counters plus 3 red counters. If we put this into our 10 frame, we can see that we've filled up 6 frames in the 10 frame. So 3 plus 3 equals 6. Another strategy for our first graders is the doubles plus 1. Now, this strategy can't be used until the students know their doubles facts, but once they do have their doubles facts down, doubles plus 1 would be, for instance, if the add-ins are 4 plus 3, they can be thinking of this as 3 plus 3 plus 1 more. So 4 plus 3 would be equal to 3 plus 3, which equals 6, plus 1 more equals 7. And if the students need a visual of this, for instance, 4 plus 3, well, 4 is the same as 3 plus 1. So now they're adding 3 plus 3 to get 6, plus 1 more is 7. In the same way, if these add-ins are reversed, 3 plus 4, the 4 breaks down to 3 plus 1. So the students are once again adding 3 plus 3, plus 1 more, and getting the sum or the total of 7. And as you can see here, we have the add-ins of 4 plus 3, 5 plus 4, and we also have in the doubles plus 1 would be 3 plus 2, 2 plus 1, and 1 plus 0, and the reverse facts. And once again, for some of these sums, students may be coming to their total by counting on, or they may be using their doubles plus 1. The only facts that we haven't covered that our first graders need to know fluently are the facts of 5 plus 3 and 6 plus 3, and the switch around facts, 3 plus 5 and 3 plus 6. So I would say for these facts, we could set up a rule that 5 plus 3 would be the same as 5, and we could count on 3. Or we could look at 5 plus 3 as 3 plus 3 plus 2 more. And for 3 plus 5, I would look at it the same way. And for these final set of facts, 6 plus 3, I would look at it starting with 6 as 6 plus 3, and we could use either the doubles fact of 3 plus 3 and then having to add 3 more on, or we could start at 6 and count on 3, 7, 8, 9. And this completes all of the facts that our first graders need to know fluently. So since this standard deals with our facts within 20, we've covered our facts within 10, and on the next video, I'll cover the rest of the facts all the way up to 20. If you're interested, here is the complete standard that this video, Adding Within 10, is based upon. Add and subtract within 20, demonstrating fluency for addition and subtraction within 10. Use strategies such as counting on, making 10, for example, 8 plus 6 is equal to 8 plus 2 plus 4, which is equal to 10 plus 4 is equal to 14. Decomposing a number leading to a 10, for example, 13 minus 4 is equal to 13 minus 3 minus 1 is equal to 10 minus 1 is equal to 9. Using the relationship between addition and subtraction, for example, knowing that 8 plus 4 is equal to 12, one knows 12 minus 8 is equal to 4. and creating equivalent but easier or known sums. For example, adding 6 plus 7 by creating the known equivalent 6 plus 6 plus 1 is equal to 12 plus 1, which is equal to 13.